Hey geometry team, welcome to Unit 10 Day 3, and we are getting into a different concept today. Today we are going to be focusing on volume of our three-dimensional shapes. Now we've been focusing on surface area, which is just an area measurement. It's just the number of squares that fit inside an object. We are now getting into volume, which is going to measure the number of cubes that can fit inside something. So now we're going to be talking more about how much space you can fit into a three-dimensional object. So you're going to have a length dimension, a width dimension, and a height dimension, no matter what shape you're looking at. Now obviously if you have something that is a cylinder, length and width and height, they're harder to measure, but we still are going to be having three dimensions that we focus on, okay? And so to start off with our rectangular prisms or cubes, in order to do volume, we're going to measure the number of cubes in it, and we'll start off by doing the area of your base. And that's just going to give you a square dimension. But once we start figuring in a height, now we're taking that area and stacking it over and over again to get a height. So to find the volume of a rectangular prism or cube, that's going to be your length times your width times your height. Okay, so we'll have a length dimension, we'll have a width dimension, and we'll have a height dimension. And you can pick whichever one to be length or width or height that you want, because it doesn't really matter on a rectangular prism, because you could rotate it and make any one of those dimensions be its length or its width or its height. It's all the same. So for example, for this rectangular prism, I can do the volume equals my length times my width times my height. I can pick whichever one to be whatever I want. So I think I'll make my length be 17. So my volume will be 17 times, I think I'll make my width be the 9. And the height will be the one that appears to be standing up. So I'll call that one 24. And so when I put all of those together, that's going to end up getting me my volume of 3672 cubic centimeters. And notice that it's talking about cubic. We are actually talking now the number of cubes that fit inside this object. And so you're going to be finding out the number of actually little cubes that will fit inside of your object. And so imagine like a Rubik's Cube being cut into a bunch of pieces. That's what we're focusing on. All right, so that doesn't get any more complicated than that. So I'm not going to do a whole bunch of examples of that. Instead, I'm going to focus on prisms of other shapes. Okay, and remember, to identify a prism, you look for the shape that's on the base that has its parallel and congruent friend at the top. So you have two bases that are parallel and congruent. In this case, I have a triangular prism. Down here at the bottom, I see that I have two trapezoids. One here and one in the back, hiding behind it, that are parallel and congruent. So this would be a trapezoidal prism. And it's important to know which piece is your base, because to find the volume of another shape, other kind of prism, you will do the area of whatever that base is using the area formula that we learned back at the beginning, and then multiply it times the height. So in this first example, my base shape in this prism is this blue triangle. And so to find the area of that base, it's going to be 1/2 the base of the triangle times the height. And so I'm going to go, okay, my height is going to be the thing that's perpendicular to a base. So here is the base of that little triangle, and here is its height. So I'm going to be doing 1/2. This base right here, it's going to match this length, so it's 12. And then the height of the triangle is this 7.3 feet. So notice this 5 along the side, that's something totally different. It has nothing to do with my triangle. I want to focus just on this triangle for now. So it's 1/2 the base of the triangle times the height of the triangle. And together that's going to give me 43.8. Then to do the volume, I'm going to do the area of that base, so now this whole area that I just found, times the height of the prism. So I'm going to stack 5 feet worth of those triangles on top of each other. And so that's going to give me this area, the 43.8, times the 5 feet high. And the total of that is going to give me 219. And then remember, I'm counting the number of little cubes that actually fit inside of here. And so this is going to be cubic feet, or feet cubed. My next example, I'm going to skip past another triangle and go straight to this trapezoidal prism. And I'm going to remind myself, okay, I need to do the area of the base so that when I find my volume, I can do the area of the base times the height. Well, this base right here is a trapezoid. It's got one of its bases is 14. The other base right here is this 36. And then its height is running right here. That's the 17.9. So focusing just on this trapezoid for a minute, to find its area, I would do base 1 plus base 2 divided by 2. I'm going to average those bases and then times the height of the trapezoid. So my two bases of my trapezoid are 14, and that needs to be a plus, and then the 36, and then that'll get divided by 2 and multiplied by the height, which is 17.9. And you work all that out, and it comes out to be 447.5. So 14 plus the 36 is going to be 50, divided by 2 is 25, times the 17.9. I'm going to take this area of this base now, this blue trapezoid, and I'm going to drop it into my volume formula. So I'm going to put in that 447.5, and now I'm going to multiply it times the height of this prism. Now notice this prism, its bases are in front and in back. So its height is the height connecting those two bases. So my height is actually running sideways here, and that's okay. Don't panic. It's fine to let that happen. So here's the height of my prism here being 25 meters. And when I put that together, I end up getting 11,187.5. And then remembering that I'm finding volume here, my units are going to be cubes. Volume is measuring the number of cubes inside. So I will be cubic meters or meters cubed. Turning it over, let's look at something else here. Oh, look, I have another triangular prism. So for this triangular prism, I would need to find the volume would be the area of the base times my height. But for this triangle, I go to work it out and I go, I've got this blue triangle and I need to find its area. So it'll be 1/2 of its base times its height. Well, I've got the height of this triangle, but oh, I don't have the base of the triangle. All I have is the hypotenuse, which is 32.5. So in order to do this one, I'm going to have to figure out what that base is. And so I'm going to have to come over here and go, okay, to find this piece right here, I'm going to have to do a squared plus b squared equals c squared. And so here's a, here's b, here's c. So I'm going to go, okay, 28 is one of my sides of my triangle, but I don't know that base. But I do know that the hypotenuse is 32.5 and I can square it. So I can do all my work here, and you know what? I don't even have a regular calculator here. We're going to be pulling up the old iPhone and doing this on here. So my 28 squared is going to give me 784 plus b squared equals, let's see if I can get it to turn. Yes, I could. So it'll be 32.5 and then squared is 1056.25. And so when I subtract and do all that work, minus the 784, minus the 784, oh, that comes out to be b squared is 272.25. But I don't want b squared. I just want b. So I'm going to have to square root the left and then square root the right, and B comes out to be 16.5. So I have found this length right here. Phew, all this work just to get this base so that now I can come up here and plug it into the formula to find this area. So see, we had to veer off our path a little bit, but now we're going to come back and go, all right, I'm going to do 1/2. The base was 16.5, and then the height of this triangle was 28. And that's going to give me 231. So now to find the volume, I can plug that 231 in as this area. But now I need a height. And this prism is, again, on its side. The height is the distance connecting my two parallel bases. So it's going to be that 31. And so my volume is going to end up being 7161. And then I had kilometers for my base dimension. And so the volume is going to be little tiny cubes inside here. So it'll be kilometers cubed. All right? So in each particular prism you do, it's going to depend on what base you have. Here I have trapezoidal bases. So I would be using my trapezoid formula to find the area of my base. If I had a hexagon for my base, I would have to use my hexagonal formula in order to do this guy. And so you're going to have to know what pieces you're using before you can use your volume equals your area of base times height. You're going to have to know what shape is this in order to solve it. For your cylinders, they're not technically prisms, but they work in exactly the same way. You've got two parallel circles that are stacked on top of each other, and that height is going to tell you the volume. So just one of those circles is just going to give you an area. But if I multiply it by how tall it is, by the distance between those ends, that height is going to help me get my volume. So the volume of a cylinder is going to be the area of a circle times the height. And oh look, the area of our circle is still just good old pi r squared. So to find the volume of a cylinder, I'm going to do still the area of the base times the height, but now I know that that base is a circle, so it'll be pi r squared. And then the volume will end up giving me that pi r squared times my height. And so let's plug in our numbers. I've got, oh, they gave me the radius already. How handy. I've got pi times 18 squared. And then the height of my cylinder is 15. And so putting that all together in this particular case, I've got 15,268.14. And even though it's rounded, I'm still counting the number of cubes that fit inside here. So this is going to be cubic inches, or inches cubed. All right? For an application here, in order to do a combined shape, here I've got a cylinder that is drilled through a prism. And they want to find the volume of the prism. Well, the volume of my prism is going to be the area of the base times the height. But I've also got this cylinder. And the volume of that cylinder is going to be pi r squared times height. And to find the area of this shape, I'm going to have to take that prism and subtract that cylinder that got drilled through, because that's a hole. It's gone from my picture. So I'm going to have to do this one minus this one. Now that I've set up what I'm going to do, I can focus in now on the details. So for the volume of my prism, I'm going to have to do the area of that base. Well, this base is a triangle. And oh, conveniently, it's very hard to see. It's very small. But there is a right angle in the corner. This is a right triangle. So when it comes time to do 1/2 base times height, my base and my height are both 5 centimeters. So I'll have 1/2 of 5 times 5, which is going to give me 12.5 for the area of this triangular base. So now when I go to do that volume, I can use the 12.5 as the area of my base, and then the height of the whole prism is 14. And so the volume of this prism, before I drill a hole in it, before it gets mangled, is going to come out to be 175 cubic centimeters. To find the volume of my cylinder now, I'm going to do pi times, oh, what is the radius of this thing? Oh, look, they gave me a 2 centimeter diameter for this hole. And so that means I have a 1 centimeter for my radius. And so for pi r squared height, I'm going to do pi times 1 squared. And then the height of the prism is still 14 centimeters. And why in the world did I write the centimeters on there? I didn't even need to because I'm not at the end yet. Silly Mrs. Cerna. And so when I put that in, I end up getting about 43.98 when you work out with whatever pi is. So now I've done these two shapes. To get the end answer, I have to remember, okay, I have to do the volume of the whole prism and then subtract that cylinder that got drilled out. So I'm going to end up doing the 175 minus the 43.98, which is going to give me the volume of the total is now going to be 131.02, and it's still all in cubic centimeters. So it's very important on these ones that are complicated to plan ahead what the big picture is and then break them down a little detail at a time and not lose track of where you are. All right, team. Thank you so much for joining us, and we will see you next time.